what I say, that will be for everyone, but this was specially for Aisha. Okay, so let's just start. So we are doing the properties of rational number. Okay, so the first property we did was the closure property. Okay, closure property. The closure property says if you are adding two rational numbers, the answer should be a rational number. If you are adding two integers, the answer should be an integer. If you are adding two whole numbers, the answer should be a whole number. Like that. Okay. So in rational numbers, basically, if you add two rational number, this property is applicable. That if you add two rational number, you get a rational number. When you subtract two rational number, this property is applicable. Like when you subtract two rational number, the answer is a rational number. In multiplication, when you multiply two rational number, yes, this property is applicable. But when you divide it, this property is not applicable. Let's see why. For example, 25 1 divided by 2 by 24, for example. Okay. So 25 by 1 multiply 24 by 2. Okay. So you solve it. So when you're solving it, you will get the answer in decimal. Okay, let's just see it like this. 2, 1 multiply by 1, 3. Okay. So this was in division. Yes, so I will multiply it. So it will become 3 upon 1 like that. So when you solve it, it's not always obvious that you will get the answer in rational number. You can get the answer in points as well. So that's why the closure property is not applicable when you are dividing two rational numbers. Is it fine with everybody in the class? Along with Aisha?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, great. Now let's just move to the second property. So from Aisha, from second property itself, we will start writing. So from second property, I should just leave few lines like how you are making the notes for the properties is. First, you are writing first closure property, the definition of closure property, then you are making a table. This not the entire table, only this. Like this. This over here says operation, addition, subtraction, multiplication, division, and here close or not. Tick, cross. This table you are making. So leave the space accordingly because you need to write the closure property over there. Okay, 2 lines for definition and I think 3 lines for this table. Okay, there's leave 5, 7 lines and then start with the second property. Okay.
Okay, ma'am.
Okay. Now, one more thing. In my class, the rule is when I'm teaching, nobody will write. Once I'm done teaching, I'll give you 2 minutes to write it down. So, no need to worry. Okay. When I'm teaching, just look at the screen. Okay, students. So, let's just start. Now, coming to the next property, which says commutative property. So, this shows that the position of number does not matter. Okay. That is, if you swap the position of the number, then also the result would be same. Clear? Okay. So that's,
Yes, ma'am.
for example, if I am doing it like this, 2 plus 3, I am getting 5. If I do 3 plus 2, I get 5. That means the position of the number doesn't matter. Okay. So, wait a minute. Okay, one more thing, Uzair. I know you already, but why you are in this class?
What, ma'am?
You are in 6th grade, right?
No, ma'am, I'm in 7th grade.
You're sorry, 7th grade, but this is the 8th grade.
Who was given the time of
I think by
Yes.
mistakenly they shared. Your class is tomorrow. Okay?
Okay, ma'am.
Okay, so your class is tomorrow. You will get the link again for tomorrow class. Okay? Clear,
Okay,
Uzair?
ma'am.
Yeah, you can
Yes,
leave the
ma'am.
meeting. Okay, I didn't notice. Okay, coming back. So this is clear to everyone that 2 plus 3 is 5, 3 plus 2 is also 5. So position of number is mattering over here.
No.
Sorry, everybody know, right? Anyone who says that yes, ma'am, position is mattering? Right? So you can say the position doesn't matter. What matters is your answer. You can do 2 plus 3 or 3 plus 2. The answer should be same. So this is what your commutative property says. That the position of numbers doesn't matter. That means even if you swap the position, the answer would be or the result would be same. Okay. Now let's just see whether it is applicable or not. So you, ma'am, you are not going to write this. So when you add the numbers, it is applicable. But when you subtract, it is not applicable. When you multiply, it is applicable. When you divide, it is not applicable. Clear? Yes or
Yes,
no?
ma'am. Yes, ma'am.
Yes? Okay. Yes. Now coming to the next property, which says associative property. Okay. So I'm just explaining you, and then you people will write it all together. Okay.
Okay, ma'am.
This shows that the grouping of number doesn't matter. That is, we can use operation on any two number that will result that the result would be same. Clear? Now let's just understand what they are saying. For example, 2 plus 3 plus 1. Okay. And here I wrote 2 plus 3 plus 1. Fine? Fine, fine. Everybody
Yes, ma'am.
got it? Yes. Okay. I just want yes from everybody. This is the rule of my class.
Okay, ma'am.
So if I'll get only 2 yes, that means only 2 students are understanding. If I will not get all the, like in my class, I have 1, 2, 3, 4 students. So I just need 4 yes. Fine?
Yes.
Okay. Now let's just solve this. So 2 plus 3 gives you 4. 4 plus 1. And here 2 plus 4. Yes? Okay. So 4 plus 1 gives you, sorry, 5 plus 1 gives you 6. And here also you get getting 6. So even if I make a group of these two number or these two number, is it mattering? The answer is same now. So group matters, yes or no? Okay, Manal, you can answer in chat. Okay. Tell me. If I am changing the group, is it mattering?
No, it doesn't.
Yeah, the answer is same. What matters is your answer. Getting it? Aisha, Abdullah?
Yes, ma'am.
Okay. Yes, so that means it doesn't matter. So this is what your property says. Associative property shows that the grouping of number doesn't matter. That is, we can use operation on any two number first and the result would be same. Clear? Okay?
Yes, ma'am.
Okay. So over here, let's just see in rational numbers. In addition, this is applicable. In subtraction, ma'am, not applicable. In multiplication, applicable. In division, not applicable. I hope I have made myself very, very clear. Yes?
Yes, ma'am.
Okay. So I'm just, for recall, I'm just recalling all the properties. First is the closure property. So closure property says if you add two rational numbers, the answer should be rational number. Okay. Second, commutative property. Commutative property says the position of the number doesn't matter. Position doesn't matter. And the third one, associative property. So associative property says the group or grouping of the number doesn't matter. I hope I have made myself clear for all. Students, understanding the property is very, very important because most of the questions comes directly from the properties. Like they will make a question here and just by looking you have to tell which property is applicable here. Or they will give you some few numbers and they will ask you follow associative property to solve this question. So understanding just by looking at the question, you should understand that, okay, this is a closure property, this is the associative property like that. Is it clear?
Yes, ma'am.
Oh. Aisha, I didn't get yes from you. You didn't get? Aisha, you didn't get? No? Sorry, you are not audible, Aisha. You got it, right?
Yes, ma'am.
Okay. Because you are today new student, so you don't know how I teach, right? So for me, considering you is very, very important, and asking you again and again is important whether you are getting it or not. Okay? So just whenever I ask you, just answer it yes or no, because I'll not then I'll get to know that okay, you are getting. Okay? Okay. So now students, let's just start. Write the commutative property. Okay. And then make a table. Okay. You can see this table. I've already told you how to make the table. So
Yes,
for
ma'am.
Aisha, I'm just repeating it once again because Aisha is new. Okay, I'll repeat it again. So what you have to do when you are making, first you will write the property, then you will make a table like this. Okay, this. So over here you will write operation, the one here written. Then addition here, subtraction, multiplication, division. And here you will write commutative, right? And then yes, no, yes, no. This is what you have to do. You don't have to write this. Fine with everybody? Everybody
Yes,
got
ma'am.
it how to make the notes?
Yes, ma'am. Yes, ma'am.
So quickly write down this and then I'll scroll to the next property, associative property. The same thing you have to do over there as well.
Done, ma'am.
Okay, everybody done? Commutative property is finished?
Yes, ma'am.
Yes, ma'am.
Anyone who is still writing it? If you are writing it, I'll wait. Others, I'll scroll. Okay, I think everybody is done. Now, you will write the next property, associative property. Okay. Okay, so the over here in associative property, I'm just making a table here. Okay, it's the same. Yes, no, yes, no. Okay, so that they have made it vertically, you have to make it the same one. Okay, the previous one you have to copy and just copy yes, no, yes, no. Clear? Everybody?
Yes, ma'am.
Yes, ma'am.
Okay, quickly do it and then we will do the next property.
Done, ma'am.
Okay, everybody is done? Everybody done? The table also?
Yes, ma'am.
Yeah, I'll just wait for 2 more minutes and then I'll scroll, okay? Everybody finished?
Yes.
Everybody finished?
Yes.
Okay. Now, let's just move to the next one. The role of 0. Okay. So that is known as additive identity. Okay. So 0 is the additive identity for whole number, integers and rational numbers. That means if you add any number with 0, what you will get? If I add 2 plus 0, what I get? Tell me, students.
2.
2. The same number. Right? So that is what? 0 is the additive identity. Okay. So you will write this till here. Then 1. So if I multiply any number with 1, what I get?
Yes,
The same number.
Same number. Right? So 1 is the multiple identity for whole number, integer and rational number. So no need to write this, just write this. Okay, that means if you multiply any number with 1, you get the same answer. Okay, good man. And good everyone. So quickly write down this. Okay. Okay, everybody done?
Yes, ma'am.
Okay. Anyone who didn't get? Okay, I'll just wait for 1 more minute, and then I'll move to the next one. I guess everybody is done now. Yes.
Yes, ma'am.
Okay.
Yes.
Now let's just do the negative of number. A negative additive inverse. See, so it means over here in added you were multiplying it with this. So that means even if you multiply it with 0, negative number, the answer would be 0. Like that means, for example, if I'm multiplying -2 with 0, the answer would be 0 itself. Okay. Then multiplicative inverse means, like for example, this a upon b is multiplied by is b upon a. Even if I write 2 upon 1, right, or 2, both are the same thing, right? Inverse. Clear? So when I say inverse, that means, for example, 2 upon 3. 3 upon 2 will be the inverse of 2 upon 3. Like denominator will become numerator, numerator will become denominator. Fine?
Yes, ma'am.
Okay. So we quickly note down this, and then we are going to discuss the last property, which is the distributive property. Okay.
Okay, ma'am.
Everybody done? Yes?
Yes.
Yes, ma'am.
Okay. Now let's just move to the distributive property. Okay. So the distributive property says you have to distribute yourself. For example, this is you and these are the students in your class. You are distributing toffees or chocolates. You will first distribute it to the first person and then to the second one. Okay, clear?
Yes, ma'am.
Got it? So let's just see, for example, A and inside it is B plus C. Clear? So this A would be first greeting this one. So A multiplied by B, right? And then plus, then A multiplied by C. Fine? This is called distributive property. You are distributing yourself. So let's just see an example. 5, 3 plus 1. Okay, or 2, let's just say. Okay. So 5 multiplied by 3. Okay. Plus 5 multiplied by 2. So 5 multiplied by 3 is 15 plus 10. You got 25. Clear?
Yes, ma'am.
Clear?
Yes, ma'am.
Okay. So this is called distributive property. So I hope I have made. See, in case if it is like this, 6, 3 plus 2. Sorry, 3 minus 2. So what you will do? 6 multiplied by 3 minus 6 multiplied by 2. So 6 3s are 18 minus 12. So you got 6. Yes? Fine with everybody? The distributive property, how to solve it?
Yes, ma'am.
Yes?
Yes, ma'am.
Okay. So first you will write it, then
Yes,
I'll give you
ma'am.
some question to solve. Sorry? I say you didn't get?
No, ma'am, got it.
Okay, okay. Okay, so now you will write distributive properties and you will write this. Distributive property of multiplication over addition and subtraction for rational number. And this the same thing. I took the example of A, B plus C. They have took P, Q plus R. So if you want to write A, B plus C equals to AB plus AC, or A, B minus C equals to AB minus AC. You want to write this? It's your choice. You want to write PQ? It's your choice. Clear? Quickly write down this and then I'll give you one question to solve for distributive property.
Okay, ma'am.